All right, let's talk about something absolutely fundamental in Java, something every developer really needs to get a handle on, the powerful and super useful collection framework. So you've been there, right? You're coding in Java and suddenly you've got this pile of objects, users, products, data points, whatever it is, and you've got to store them, find them, and manage them. And let's be honest, it can get really messy really fast. But what if I told you there's a solution for this that's already built right into Java? And not just some slapped together fix, but one that's standardized, highly optimized, and just ready to go. And that solution is the Java Collection Framework, or JCF for short. You can think of it as a master plan, a complete toolkit designed specifically for representing and handling groups of objects. Seriously, it's designed to save you a ton of time and effort. Okay. So why is this framework such a big deal? Why should it be your absolute best friend when you're working with data? Let's get right into it. Well, it really comes down to 4 huge wins. First, you code less. A lot less, because you're not sitting there reinventing basic data structures from scratch. Second, your code actually runs faster. These are highly tuned, battle-tested implementations. Third, it standardizes everything, which makes your code so much easier for you and for others to read and maintain. And finally, everything just works together seamlessly. It's just a massive win-win all around. Now, to really wrap our heads around this, let's use a little analogy. I want you to think of the JCF as your very own digital organizer set. Imagine you have the perfect set of containers for any situation. You've got a container specifically for things you need to keep in a certain order, another one that only holds one-of-a-kind items, and a third one with little compartments for paired things. The JCF gives you the blueprints for all of these. In Java, we call them interfaces. So let's look at these core blueprints. First, you have the list. Think of this as your to-do list. Everything is in a specific intentional order. Then there's the set. This is like a collection of unique stamps. No duplicates allowed, period. And finally, the map. This is your address book, right? You have a unique name, the key, that links directly to a phone number, the value. These are the main ideas you'll be working with. Okay, so we have the blueprints, but a blueprint isn't the container itself, right? You need to actually pick the real physical tool for the job. And this is where we talk about the actual implementations. When it comes to lists, you've got 2 main players, array list and linked list. And the choice is all about what you're doing. Do you need to jump to item number 500 in a split second? Array list is your champion. But what if you're constantly inserting and deleting items from the middle of your list? Well then, linked list is way, way faster for that specific task. Now what about sets? The decision here is usually even simpler. Do you care about speed or do you care about order? Hashset is your speed demon. It's ridiculously fast because it just doesn't care about order. But if you absolutely need those unique items to always stay sorted, then treeset is what you're looking for. And you'll see the exact same pattern with maps. Need lightning-fast lookups by key and couldn't care less about the order? Hash map all the way. But if you need to loop through your map and have the keys come out in a nice sorted sequence, well, that's what tree map is built for. See? It's all about picking the right tool for the job. Okay, enough theory. Theory is great, but seeing the code is what really makes it click. So let's jump into a quick, hands-on demonstration. First up, a list. We're making a simple array list, and we're just going to add 3 strings to it. Apple, then banana, and then apple a second time. And check out the output. It's exactly what you'd expect. Apple, banana, apple. The order is kept perfectly, and yep, the duplicate apple is right there. A list just holds what you give it in the order you give it. No magic. All right, now let's try the exact same thing, but this time with a set. We're creating a hash set and adding apple, banana, and apple again. And boom, look at the output. Apple, banana. So what happened to that second apple? The set just ignored it because that's its whole job, to make sure every single item inside it is unique. Pretty cool, huh? Okay, last one, the map. We're creating a hash map. First, we'll put in the key 1 with the value 1. Then, key 2 gets the value 2. But now watch this. We're going to try to put something in for key 1 again, but this time with the value uno. So what's the output? 1 entry for key 1. See that? There's only 1 entry for key 1. The map basically says, hey, A key can only point to one value, so when we added the new one, it just overwrote the old one. Simple as that. Whew, okay, that was a quick run through. So let's just boil this all down into a super quick reference guide with the absolute must-know takeaways. Think of this as your cheat sheet. Just lock these 4 points in your brain. List, it's all about order, and duplicates are totally fine. Set, its one job is to prevent duplicates. Map, it's for your key value pairs, where every key must be unique. And one last really important pro tip. By default, these collections are not synchronized. So if you're working with multiple threads at the same time, you've got to be careful. That's a big one to remember. So there you have it, the Java collection framework. It's not just some obscure feature. It's a core part of writing good, clean, professional Java code. It's your ultimate toolkit. So the real question is, now that you've got the right tools for the job, what are you going to build?